Hi everyone and welcome back. In the last video, I introduced the Penrose diagrams. How can we construct them and what can we read off from those diagrams? The causal structure of universe and infinity. I also introduced some vocabulary with the past time like infinity and all of those. And in this video, we'll briefly discuss two examples, namely the mapping of 3 plus 1 Minkowski onto the target space 1 plus 1 and the Schwarzschild black hole with collapsing star. So the first example is the mapping of 3 plus 1 Minkowski onto 1 plus 1 target Minkowski spacetime. We can do that because of spherical symmetry from the 3 plus 1 Minkowski spacetime, which means that we can take a theta slice and a phi slice without loss of generality. So then we can just construct our Penrose diagram with time going from bottom to the top, and we are left with R, since theta and phi will not be represented on this diagram. All right, so this is R equals 0. And then we are just left with this diagram where we can identify the past time like infinity, the future time like infinity. We are left with only one space like infinity. And of course we have the future null infinity here and the past null infinity here. And any point, for example, this one, is a sphere. In reality, it's just that here it's a theta and phi slice. But otherwise it is a sphere. And so we can just read off the same causal structure, namely that an eternal observer will come from the past time like infinity and go all the way to the future time like infinity. That at point P here, for example, this will be its light cone. So it will seize this light and could emit this light in front of him or her. And that's basically it. It's an easy example. The next example, sorry. The next example is the space-time where a Schwarzschild black hole with collapsing star happened or occurred. So it will look like this. So this is R equal 0. Again, we can see time like this and the radial coordinate like this. And that's where the big change is. So this is the mapping of space-time with Schwarzschild black hole from collapsing star. I don't know how to write that. I will just write SCH for Schwarzschild onto 1 plus 1 Minkowski target space. And so here we have the past time like infinity, here the future time like infinity. Again, we're left with only one space like infinity. This curved line represents the singularity of the black hole. This is the collapsing of the star, and this is the event horizon. So it is pretty easy now to see the causal structure of this space-time because, of course, if you are here, your light cone looks like this, and there is no way you can escape the singularity. So it means that once you cross the event horizon, it is easy to see why you will never escape the singularity. And an eternal observer will still go from there to there, to the future time like infinity, without never need to cross an event horizon. We can see, as we know, that the event horizon is a null line. The singularity is a space-like line, an event in your future and no longer a point in space, but a point in time. Still, any point represents a sphere because we still assume spherical symmetry. And we're in a space-time with a collapsing, with a black hole emerging from a collapsing star. We basically all live here in this space. We all live in this region of the future time like infinity, which is just a point here, but again, it's at this space, it's a whole universe or universe, basically. Also, you can see that an observer that crossed the event horizon, so for example, an observer here, will, inside of the black hole, see the light of the collapsing star, which is quite confusing. But before crossing the event horizon, of course, you will just see a black hole. Once you cross the event horizon, you will see everything that has happened since the formation of the black hole. Yes. All right. An extra example that we can discuss is still the Schwarzschild, oops, be like this, Penrose diagram, is that whether or not you fall feet first into the black hole, you will never see your feet hitting the black hole, and this is because if we really exaggerate now, if we say, for example, that so that was my time coordinate axis. So if we say that you fold feet first. Oh, no, it's not working. All right, sorry, give me 1 minute. Yes, so, all right. You fold feet first. Your light cone is something like this. And you see that your feet are gonna touch, are gonna cross the event horizon and touch the singularity before you, because that was the radial coordinate axis R. So you see that your feet are closer to R equals 0 than your head, and this is your light cone. So you can represent what you see along the path as those. At the event horizon, you will see your feet at the event horizon, but of course your feet, they will be inside. You will be like this, but what you will see will be your feet as they were at when you were at the event horizon, and when you will crash into the singularity, you will never see your feet hitting the singularity because of the light cone. I don't know. Actually, I'm terrible at explaining this. I don't know how to explain it better. We have, this is the singularity, and you are falling. This is the radial component R, the event horizon. This is R equals 0. You are falling. This is the word line of your feet, the word line of your head. And when your feet have eaten, or I mean, your feet hit already the singularity, but your head still not. And when your head does, you see that your past light cone, so everything you have experienced, and your future light cone is everything you did not yet. And this is the present here. This is the present. Right. Your feet will never be in your past light cone, so you will feel like you hit your head, before your feet, but in reality you do not. But it's just an example of what you can read from the causal structure with the Penrose diagram. All right. So those were example of Penrose diagram. Thank you for watching. Bye.